All right, in this video we're going to be talking about extension methods. And extension methods in C# is a way to add methods to types. And basically that's all it boils down to. But the implications of that means that we can attach methods to classes that have already been written or have been imported from other assemblies even. But not only classes, we can attach extension methods to enumerations, to delegates, to interfaces even. So it provides a lot of flexibility in the kinds of things that we can do.
Well, let's go and get a new project up. I think a great example to give them right out the gate here would be adding some sort of functionality to the string class.
Sure. So by default, string is a sealed class. So adding functionality to it via inheritance is disallowed. So for example, obviously this will fail because string is a sealed class.
Exactly.
So that's generally the classical way to add functionality to a class is through inheritance. But extension methods are not only a way to not have to use inheritance, but they allow you to add functionality to types in code without having to change the actual types of the parameters and stuff, for example, if you kind of see what I'm saying.
Mm-hmm.
But so to define an extension method, basically what we have to do is create a non-generic, non-nested static class. So I'm going to go ahead and call a static class, and we're going to call this my extensions. The actual with the class keyword, of course. The actual implementation or the actual name of this class is irrelevant, just a heads up. But what is relevant is the namespace that is declared under, and we'll look at that later. So to create an extension method, we have to create a static method with a return type and a parameter list and or a generic parameter list. And that's just all normal, as you would expect. The only difference is you'll see that, like for example, if we wanted to make a isEmpty method on the string class, we would begin our parameter list with a this modifier.
And that really is the key thing there. I mean, other than, first of all, this having to be a method that's static inside of a static class, but then the very first parameter here being this.
Yes, exactly. And the next token is going to have to be a type. So let's go ahead and say string. So this string, this is the modifier, this is the type, and just a heads up, you cannot have any other modifiers with this modifier, so no ref, no out. Also, this has to be the first parameter. This can't be the second or third.
Correct. Also, just even though you just did mention that string here being the type, this is the type. I just want to make sure that everyone is clear on this. This is the type that we are adding this extension method to.
Yep. Then what follows is just going to be a normal parameter identifier. So just normal parameter name, and people have different conventions for what they use for extension methods. I generally do that.
And it makes sense, this and that.
Right. And so what this is actually this in the context of the object that we're invoking it from.
Right.
So if that didn't make any sense, let's go ahead and say return that trim length is is equal to 0. So so this is my isEmpty method. It's just going to say if the string is just a bunch of white space or is null or empty or whatever, it'll go ahead and return true. So now I'm going to go ahead and create a string variable. And if I do my string dot, you'll see something cool. Down right about here, if I know my alphabet properly, we'll see the isEmpty method has shown up. This isn't a built-in method to the string class. This is actually the method that we just defined up here.
Also, go ahead and point out the icon difference as well.
Yes, in both 3Sharper and Visual Studio IntelliSense, the icon will be different. It'll have that little down arrow on it. So now we can invoke this method just like normal. Now, if you're looking at this code, you might be asking what exactly is happening. Is the C# compiler actually going into the string type and editing it in some way? The answer is no. Extension methods are a C# compiler construct. They have nothing to do with the CLR. They don't have any runtime representation. Instead, when the C# compiler sees this syntax, it will make a note of this method being an extension method, and it will add the appropriate metadata to the method when it's compiled into the assembly. Now, when we invoke a method on an object, and that method is not found anywhere inside of that method's type, so the method they can't resolve the method at all. It's an invalid method. The first thing the compiler will do before throwing its hands up is search for the valid extension methods that it could invoke as a part of this object. So you'll see that as part of its searching, it's going to make sure that there's an extension method that is accessible within the current namespace. And what I mean by that is this, like I said, the name of this isn't important, but where it exists in the namespace is. So because this class was defined in a namespace that is also encompassing our main method, this extension method is accessible. If, however, I were to move it into another namespace, now it becomes red because the C# compiler can no longer resolve it. It's no longer within the same namespace. In order to resolve this, we could go ahead and add a using statement at the top to import all of the extension methods defined in that namespace. And if you want, you can pretend this is a different file, because saying using blah then declaring blah is kind of confusing.
Right.
But the point is that you always have to import, either declare your extension methods within the namespace that they're used, or import them with the using statement at the top.
Well, do another one. Do add an extension method to integers, to int.
Well, we can go ahead and just do static, public static. Let's do a worthless one. Let's do add.
Very nice. I like the example of having multiple parameters.
If you don't know what RHS stands for, it's called right-hand side. It's what you use often for things like that. But anyway, as just a naming convention. Anyway, so yes, now we have an int. It's called myInt. And now we have a method on it called add. And you see that I don't believe the Visual Studio IntelliSense will actually show this, but the ReSharper one does. You'll see that this method does have two parameters, but we're only required to pass in one argument. And that in that case, this is the second parameter to this method. Remember, the first one is the object that we're actually calling on. So we can go ahead and pass in something, and the result of this will obviously be 20.
Well, you going to prove it?
Well, I could. Just go ahead and import a system.
Just keep asking everyone to take your word for it. There you go.
And we see 20.
All right.
So as far as how extension methods actually work, this actually, in the way that they do work, actually opens up some really neat possibilities for extension methods. But when the compiler sees that we want to use an extension method, such as both these cases, it finds that there's an extension method being imported. It knows that there's not an already is empty method on the object, blah, blah, blah. What it's going to do is it's going to do, or sorry, wrong one, that. Or, in this case, that.
Very nice.
So what this is doing is this is actually invoking the extension method as a static method. So this is how the C# compiler can get away with adding extension methods, but without having to insert any crazy stuff into other assemblies, which would be weird.
Exactly. Now, go ahead, please.
But the cool thing that we can do with this is, because this is actually what gets compiled. Let's say that we wanted a method called, it's going to be a strange looking method, because normally this would not be even a legal, well, it would be a legal method, but it wouldn't work the way you'd expect it to. Yeah, my bad. Okay, so now we have an is null or empty method, and you might think that this looks a little strange because we're comparing that to null. Now, under normal circumstances, if this was a member on the string class, and if you were trying to invoke this method on the string class, but that string object that you were using was null, you get a null reference exception. But because of the way that C# works with extension methods, literally null is passed in just as a normal argument, which is legal to be null. So basically, we can go ahead and prove right now that if I were to take, oh, this is going to be weird. I'm just going to break this out so it's a little less weird. So if we were to do this, we could actually invoke a method on it and run it, and we actually get a response. So it's a different way of thinking about things, but it also opens up a lot of really cool possibilities that are a bit beyond the scope of what we're talking about here.
Sure. Now, some of the other things that you had mentioned at the beginning of this video, that we could add extension methods to things like enums, delegates, interfaces. Give us some examples. Let's start with something really simple, like an enumeration. Just because it's, I don't know, to me it looks so, it's weird.
So yeah, so go ahead and let's sneak this out there for a second so we can actually work with stuff without getting cluttered. So as far, or as enumeration, for some reason I thought you said enumeration.
Oh, no. Just an enumeration, an enum.
This is kind of weird. I'm going to actually nuke this namespace now because it's actually kind of getting on my nerves.
I was wondering how long that was going to take. Okay.
And let's go ahead and fire up a enumeration, and then let's call it, I don't know, yes, no.
Best ever.
If you don't read the daily WTF, you really should. Anyway, we can actually attach extension methods to that enumeration for some weird reason. I'm not quite sure I
find it interesting. I've not found a use for it, but it is very cool that you can do this.
So now we're adding a print me method to our yes no enumeration. And so now we can say var no equals yes no dot no, and we can do no dot print me. And this will work properly.
That's awesome.
So, I don't know why that would ever happen, but still though, you can still add methods to enumerations or delegates or especially interfaces. Now the interface one is really, really cool, especially because it's used by Link itself to extend the functionality of every single object that implements IEnumerable without having to actually edit all of those objects to support all of the functionality of Link.
Okay. Examples.
So let's say this is actually going to bring up an interesting one. Something that we need to talk about is how do generics play in with extension methods.
Very true.
So let's say we have a let's say we create a filter or filter out less than 5 method, and then we take in what we want to do is we want to have we want to return an IEnumerable of int, and we want to extend an IEnumerable of int. So we do this IEnumerable of int that, and then we can just say for each var item in that, if item is greater than or equal to 5, yield return item. So now we basically added on some functionality to every single object or every single class that implements this IEnumerable. And the cool thing is we're adding functionality to an interface, but the limitation is obvious that we can only write our code in terms of what the interface itself exposes.
Exactly.
In this case, this interface only exposes the getEnumerator method.
Mm-hmm.
So now I can go ahead and do and create a new array of ints, and I can do array dot filter out less than 5, or I can create a list of ints.
Once again, because both implement IEnumerable,
we can now say list filter out less than 5. So
let's say that you had a list of strings. Now
right.
go ahead and show that.
Well, in this case, you can't really compare a string to an int, but
right.
What you can do is this generic type argument can actually not only be genericized, but
no, I was just making the point that we've actually locked ourselves to a condition
right.
that we can only deal with IEnumerables of ints.
Exactly. If we were, what we can do in addition to that, we can attach ourselves to essentially, I guess you could say, a wildcard of any generic type argument passed into this interface. So let's say we return an IEnumerable T source, and let's just write a, I don't know, just a normal filter method, I guess.
Okay.
IEnumerable of T source, and of course we have to provide our generic parameter list. And then we can take in a function that takes a T source and returns a bool, and we'll call this guy predicate, and we'll run off to the end of the lines. Let's drop that down there. So now you see that we're writing an extension method for a generic interface, but we're providing the generic argument as part of the method itself.
Mm-hmm.
So we can attach ourselves to virtually any IEnumerable. And because of generic type inference, we don't need to specify any more generic types in order for this to work properly. So let's go ahead and just say, for each var item in source, if predicate item, yield return item.
Awesome.
So now we can do list.filter, and then you see that
basically we have the IEnumerable, in this case int source is grayed out. It's just ReSharper telling us, of course, that's not required. We're going to start with the func.
Right, and so like Jason said, the generic type argument has been inferred, and then not only has it been inferred, we've reused it on this func, which allows us to pass in a lambda, and without even specifying our type.
Mm-hmm.
So we can just do a is greater or equal to 5. I mean, what we pass in as the predicate is irrelevant.
Yeah, that's just very cool, though.
Yeah, and we can even, the only things that we can't actually attach onto are pointer types for unsafe code. We cannot attach onto dynamic, and actually that's about it. We can't attach onto pointer types or dynamic.
Do you feel like just pulling another example out of thin air? How about something with delegates?
Yeah, well, we can, let's see, a good example of...
Now, guys, please bear with him. He's actually having to pull this out of thin air.
Well, I have a good one.
Oh, cool.
Terrible code, but it'll work. So we can now actually go ahead and say action, my action equals, and then, I don't know, we can throw a new invalid operation exception, or whatever kinds of exceptions we want. And of course, we need to, sorry, my brain, break this out onto multiple lines because it doesn't like that, because it needs to be a return if it's the same line. And now we can do my action dot eat exceptions. Yeah, well, I know that's a terrible piece of code, but the point is that we can do lots of neat stuff with attaching ourselves to delegates. And not sure about enums, but we can do that anyway. Interfaces especially are awesome. On top of all of that, we can also extend object, and we can also extend object in a more type-safe way. So I'm not going to actually write out any usage examples. I just want to show you the syntax for declaring these extensions. But I can say... I can do this. This is perfectly legal. I have now added an extension method to every single object in existence. Or rather, if this class is imported into the current method that we're using, then this method will be available on every single object.
Correct. And you can demonstrate that real quick. You can make a couple of different local variables down below of different types.
Well, I mean, I don't really have to. I can just use.
You can just do it right there. I mean, exactly. Hey, da-da.
My string.onAllObjects and so on.
Awesome.
But there's one better way to do this actually. Through generics, and this can be kind of funky looking, but it works. So basically, these two lines are doing an equivalent thing. It's just one is generic and more type safe, and the other one is not generic. Well, in addition, this one will cause boxing of value types, whereas this one won't. But basically, they do the same thing where we've essentially attached these methods on every single object in existence. And again, I can prove that because now we have on all objects too, and so on. And then if you wanted to get crazy, you could also specify that we only want these on value types, or we only want this extension method on reference types.
Awesome.
Or whatever we want. So yeah, that's about it.
Yeah, extension methods are extremely powerful, very cool, and something we make use of quite a bit in the stuff we do over here at 3D Buzz. So anything else, Nelson, you want to add in on this?
No, that's about it.
Okay, well, that will conclude this video. Thank you very much.